changing the input values. And so what we're having to do, if I wanted to say move it k units to the left, so if I want to use, instead of k, we use h. What I need to do is I need to take my f of x and instead make it f of x plus h. This f of x plus h is now causing my graph to go from where it originally was and shift it h units to the left. Now, I realize that may seem somewhat counterintuitive because x plus h, if I'm adding something in here, most people will think, okay, well, that's going to actually move it to the right. But that's not true. Okay? The effect of changing things on the inside is sort of a little bit backwards of what your intuition tells you should be. Okay? This will move our graph to the left. Positive changes to our inputs are going to move it to the left. Negative changes will move it to the right. Okay? So in our graph over here, if I go f of x plus 1, y equals the quantity, or f of x plus 1, right? F of x plus 1, in terms of our function, that becomes x plus 1 whole thing squared. The graph of that is now over here. Something like that. That's our So horizontal shifts, we're making changes to all of the x input values. We're moving them left or right, depending upon which way we want to go. So h units to the left, f of x plus h. If I wanted to go h units to the right, I take f of x and I replace it with f of x minus h. So that little change on the input side there is going to cause us to shift to the left and to the right. All right, so let's take a look at some examples of writing out what these function changes will look like. So I'm going to describe the shift I want, and I want you to find the appropriate function representation. So the first one I want to, all of these are going to be f of x. I want to shift f of x up by pi units. Second one, I want to shift left by 3 units. Third one, I want to shift down 2 and to the left. Oh, 6. And then for the fourth one, shift right. 1 unit. And up 6 halves. 6 halves would be 3. 6 fifths. Okay. So here are 4 verbal descriptions of how I want to move my graph or my function f of x. What I want you to do is tell me, what does the representation of that look like? It's like f of x plus something, or f of the quantity x minus something. What is that going to look like for each of these verbal or written descriptions? No, we're just f of x. F of x is an arbitrary function at this point. So. left by 3 units.
That must be if x was 3, but 3 is
So in this case, we're looking at f of, and since it's a left shift, since we're moving it horizontally, this 3 must be what's happening to the input values. I'm changing the input values. So that's going to give me an f of x. Since I'm going left, it should be a plus 3. Plus 3. All right. The third one here, we're combining 2. We're shifting it down, and we're shifting it left. So what happens there? First thing, moving left, that's going to be an f of the quantity x plus 6. And then down everything, so that's going to be our minus 2 in the end. Okay. And then what about the last one here? We're going to go to the right 1 unit, and we're going to go up 6/5 units. Okay. Here we're moving it to the right, so that's going to be a minus. So that's going to be x minus 1 up 6/5 units, so plus our 6/5. Okay. Very good. Coming up with these expressions, knowing how these expressions are changing our graphs, are going to make it very easy as we progress through the course. You're going to be able to see, okay, what has this change done to my graph? You're going to be able to graph it very quickly and easily if you can identify how these inputs or how these combination of shifts and scales, how they're going to affect what your picture looks like. Okay. All right, so these are the shifts that we can work with. There are also other things that we can do to functions to get them to look different. We can also scale our graph. Scaling our graph is basically, carefully don't drop your stuff. Scaling our graph is basically making the picture not necessarily move left or right, but causing it to either become more steep in certain places or less steep in certain places, maybe stretching it out a little bit further here and there. Those are the kind of things that scaling does to our graph. And if we look at things like that, we can scale in a couple of different ways. We can do So we can do vertical scaling. And oftentimes you'll see these written as stretching or compressing. And basically this is sort of very similar to what we did with the shifting. Vertical scaling is causing our overall values to change by some sort of factor. And so what we're doing with vertical scaling is we're multiplying by some value. We're multiplying f of x by some value. And if this value is positive, or sorry, if this value is big, it causes us to stretch. And if that value is small, it causes us to compress. Now, you may ask, okay, well, what does big and small represent here? This is a math class and we need concrete definitions for big and small. Big, so we're stretching